All right, here's part 2 of the 13.3 video. At the end of the first video, we were able to write an equation based on the information given in this graph. So let's write our transformations of 0, 1, right? That's transformed to h, a plus k, and h plus, whoops, that's not what I meant, 1e transforms to h plus 1, ae plus k. Okay, again, folks, your biggest job is to identify which of these points given on the graph correspond to our reference points. Remember, our reference points look like this. These two spots, 0, 1, and 1e. All right, this is reflected. So we're going to expect that A is negative. So let's hope that's what we find out. This point right here corresponds to the 0, 1. So -2, 0 corresponds to this, h, a plus k. Now, looking at this graph, guys, somebody tell me what k is. Well, here's my asymptote, y equals 1. Therefore, k equals 1. It's all right over here. We know k is 1. Right here, from this right here, we know h is -2. Finally, I can say 0 equals a plus k, which equals a plus 1. 0 equals a plus 1. A equals -1. All right, well, that seems to work, right? Now, the second point, -1, 1 minus e, corresponds to this, h plus 1, ae plus k. Since we don't have to find the b, we know it's e, we know it's the base e, we're using this second point just to verify what we found from the first point. Make sure we didn't make a math mistake. All right, so if -1 equals h plus 1, well, h is -2 plus 1 equals -1. That works. Then over here, 1 minus e, a is -1. So I missed the -1 there, didn't I? Oops, let me get this right. Do it like this. 1 minus e equals ae plus k. A is -1. -1e plus k. K is 1. Notice this is 1 minus e. It works, doesn't it? So we were able to take 2 points using this up here, right, that you will be given to find the equation. So let's write our final equation. F of x equals a, right, times e to the x minus h, because h is -2, plus k. That should be our answer right there. All right, so again, your hardest part is making sure you get the which of the points on the graph correspond to the points, the reference points, right? All right, so looking at this one, excuse me, let's say I ask you the domain and range. Well, it's exponential. The domains always are real numbers. Range, it's below, right? It was reflected, so it's below the asymptote. So it's from -infinity up to the asymptote, not including domain and range. Okay, now we're going to talk about modeling. So we have this explanation at the top. Although this, right, has a base, e has a base, is at 2.718, we can use a function here so that I can have any positive base, because you write it, you write it like this. Now, e to the c is the base of the exponential. Okay, so it says solve it using the graphing calculator. Guys, this is where we're going to draw different graphs, right, for our graphing calculator. So the Dow Jones index is a stock market index for the New York Stock Exchange. For this period from 1980 to 2000, it can be modeled by this equation, where T is the number of years after 1980. So that means if T was 0, 1980 would be the year. T equals 1, 1981 would be the year. That's how they typically do that when we're working with timeline problems. Okay? It says, first of all, we have this function. I'm just going to do V of T equals 878 e to the 0.121 t. All right, we can graph that. Then it says, determine how many years after 1980 that the Dow Jones Index, that's Y, right? Where is this Dow Jones Index equal to 3,000? So we're going to graph. Now remember, here's where we have to play around with windows to see if we can see our intersections. So I'm going to graph 878 E, where are you, E? Raised to the 0.121 t, or x, right? And 3,000. So if my graph was on Zoom Standard, I wouldn't be able to see this. Because look at the number here. It's basically saying, if you plugged a 0, that we would be at 878 at year 0. So I have to go and change my window. So I'm going to make my Y, look at how high this is going to go, right? 3,000. So I'm going to put, for my Y max and min, I'm going to put my Y min, I don't need to see much, right below this. I'll say 700 is my min. My max, I'm going to say 3,010. All right, so I'm going to do Y min. So I don't need to see 0. It's not going to tell me anything. And Y max, I'm putting at 3,010. I just need to be a little above to see this intersection. Now, X min, we're going to start at 0, which is 1980. And X max, I don't know. I'm going to start with 20 because I have no idea where the intersection's happening. 0 to 20, and I have that. I'll show you what the graph looks like. Maybe we won't hit the intersection. Oh, maybe we will. It's thinking, it's thinking. So the graph actually does this and this. So we want this intersection. So remember how we did that. Second calc, going down to the intersect. First curve, yes. Second curve, yes. Guess. Here's my intersection. X equals 10.15 approximately. Y equals 3,000. So it says determine how many years after. Well, it's 10 years after, isn't it? If 1980 is t equals 0, or x equals 0, then x equals 10 means 10 years after 1980, the Dow Jones Index will be 3,000. Now we're modeling here, guys. Modeling is done to be able to predict. Based on what's happened in the past, can we predict what's going on in the future? Let's try another one. All right, here's another type of stock exchange, and this is for the Tokyo Stock Exchange. So we have, again, some modeling, 23,500 e to the minus, and this is the number of years after 1990. So that means t equals 0, 1990, right? Now, notice it wants to know when this thing's dropping. So we got to adjust our window, but they want to know when will this stock exchange hit 15,000, right? So I'm going to graph it again. Clear, clear. So it's 23,500 e to the negative 0.0381 x, and then below I'm going to put 1,500. Now, I got to change I'm going to take my Y min and my Y max. I need to know when it hits this, and it's starting at this. So I'm going to make it from 14,000 up to 24,000. Okay, just to be able to see everything. So I hit my window. I'll leave X min and X max because I don't know. I'll leave those at 0 and 20 because I don't know yet. I got to see what's going on. But my Y min is now 14,000. My Y max is 24,000. And we're going to graph it. So this is what it looks like. Notice what we have here, gang. This is decay, isn't it? This is decay. So we're going to find this intersection right here. Second calc, go down to my intersect. First graph, second graph, guess. So my intersection is y equals 11.8. I'm sorry, x equals 11.8. Y equals 1,500. How many years after? Almost 12 full years. You could say 11.8 years. The Nikkei 225 index will hit 15,000. So those are two examples of being able to model using base E growth or decay, depending on the situation. All right, there's a worksheet on PowerSchool that you will do with these problems. I think we're all set here. Please contact me if you have any questions. All right, thank you.